Hi everyone, my name is Nur Shafatin. In this video, I will present a separation and purification of polymer. Okay, the experiment's objectives. At the end of the experiments, I am able to carry out the separation and purifications of polymer quantitatively, and then I can determine the percentage of the cinnamic acid presence in the polymer by using the UV analysis. The procedure for this experiment was divided by two, which is the first one is polymer separation and purification, and then the polymer sample will undergo the second one, which is UV analysis. For the polymer separations and purification step, the students were provided with 10 ml of polymethyl methacrylates in the chloroform having a concentration of about 5% weight over volume. The solution was contaminated with the cinnamic acid to a level of about 1% weight over volume. The polymer was separated and purified using the reprecipitation method. In the first purification step, the polymer was separated from the polymer solution by precipitating it in the methanol. The polymer solutions was added drop-wise into the methanol, which is drop by drop, with a volumes of more than 5 times the volumes of the polymer solution, which is 50 ml. While adding the polymer solution into the methanol, the mixture was stirred vigorously either with a magnetic stirrer or glass rod. And then when the precipitation was completed, the polymer was filtered using a clean and dried sintered glass. The polymer was washed with a small amount of methanol and it was left to dry by suction using the vacuum pump for about 20 minutes. After that, the polymer was transferred into the small plastic container with its mass known beforehand. The samples was dried in the vacuum oven at about 50 degrees Celsius at least for 24 hours. And then after the drying process, the weights of the dried polymer product was recorded. And then about 0.02 gram to 0.05 gram of the dried polymer was kept and was labeled as polymer 1. The remaining of the dried polymer was used to carry out the second purification step by dissolving it not more than 5 ml of chloroform and was reprecipitated as in the first purification step as described before. And then the polymer obtained from this step was labeled as the polymer 2. The second part is the UV analysis. The purified polymer were analyzed by using the UV method. The UV test was done on the polymer 1 and polymer 2 obtained from the first and the second purification step. For each UV analysis, about 0.01 gram polymer samples was weighed accurately and it was dissolved in the 25 ml acetonitrile. The UV spectrums of the solution was got in the range of 300 to 200 nanometer. For data analysis, Beer's law is used, which is A equal to epsilon BC, where A is the absorption directly obtained from the UV chart, epsilon is the molar extinction coefficient, B is the cell distance, in this case B is equal to 1 centimeter, C is the concentration in the unit of mole, the M-3. So here is the results for the experiments. I create the table for part A, part B and part C. Part A is the separations of the polymer from polymer solution, which is from the first purification, where the weight of the plastics is 0.6766 gram and the weight of the plastic and samples after drying is about 0.9624 gram. So we will get the weight of the samples is 0.2858 gram. Okay, for part B is the second purifications of polymer, which is the reprecipitation method. The weight of the plastics is 0.6574 gram and the weight of the plastics and samples after drying is 0.8735 gram. So we can calculate the weight of the sample, which is labeled as the polymer 2, is about 0.2161 gram. So for the part C is the UV analysis of polymer 1 and polymer 2 obtained from the part A and the part B. So as we can see in the table, The weight of the polymer 1 that has been used for the UV analysis is 0.0117 gram, and the weight of polymer 2 is 0.0104 gram. So the volume of the sample solution used is 0.025 liter. And then we need to calculate the molecular weights of the polymethyl methacrylate. The chain is CH2, CCH3, COOCH3. And the molecular weight of the PMMA is 100.12 G per mole. And then the molecular weight of the cinnamic acid, which is C6H5CH double bond to CH COOH, is 148.16 G per mole. For the second part, which is the UV analysis, so here is the spectrum peak report for polymer 1. From this spectrum, we can see that for the number 9, the wavelength at 209 nanometer, the absorbance volume for it is 0.914. So as we can see from the spectrum, the number 9 showing the obvious peak. After that, this is the spectrum peak report for the polymer 2. As we can see, the obvious peak is labeled as number 7 at the wavelength of 206.2, and the absorbance value of it is 0.879. So these values are used in the next calculation. Okay, by referring the spectrum peak for polymer 1, we can calculate the percents of the cinnamic acids by using this formula. The M total used was 0.0117 gram, which is the weight of the polymer 1. And then the A total is 0.914 at 209 nanometer. So we take the value from the peak showing from the spectrum. And then after calculate, we can get the percents of the cinnamic acids. The percents of the cinnamic acid presence in the polymer 1 is 1.52%. And then we go to percents of the cinnamic acid presence in the polymer 2. So the mass total that we will use in the calculation is 0.0104 gram. And the absorbance value is 0.879, which is at 206.20 nanometer. So from the calculation above, the percents of the cinnamic acid in the polymer 2 is about 1.64%. So we have done for the calculation part, and then we move on to discussions. So overall, what I can say is the PMMA is formed by the free radical polymerizations of the monomer methyl methacrylate. The polymethyl methacrylate structure is a vinyl polymer, which is an ester of the methacrylic acid, CH2CCH3CO2H. The pendant CH3 groups hinder the crystalline packing of the polymer chains, since they are not allowed to rotate freely around the C single bond C bond. The resulting structure is quite rigid. The separation methods of the polymer is defined as a method that converts a mixture of substances into two or more different product mixture. Filtration, distillation, chromatography, and precipitation are just a few of the many various methods that can be utilized in the separation process. The technique used to extract the polymers from the reaction mixture depends on their structure, characteristics, and the polymerization system itself. However, to get rid of the impurities from the combination, polymer purification is essential. Typical purification processes include solvent extraction, reprecipitation, standard drying, and many others. In this experiment, the reprecipitation process was used to separate and purify the PMMA polymer. Separation methods of polymers from the reaction mixture depends on the properties of the polymer and the systems of the polymerization. Polymers prepared in the solution are usually isolated by adding the reaction mixture in excess non-solvent, and this will cause the polymer to precipitate out and can be filtered and strained. Sometimes the precipitated polymer remains in the form of suspended colloid. The polymer can be removed by cooling the mixture with ice or by adding the electrolyte like sodium chloride or diluted acid solution. Other methods such as long stirring time, shaking, centrifuging can also complete the separation. The stirring needs to be vigorously to prevent the polymer to stick together. First, PMMA in chloroform will contaminated with cinnamic acid that acts as an impurity. The solution mixture will be added drop by drop into the methanol. This will lead to the formations of the precipitate. Cinnamic acid is added during the polymerization process of PMMA as a cross-linker, which can increase the elasticity of the PMMA polymer. The polymer solution must be dropped twice into the methanol to get more and good precipitation. Extra methanol then can be used to improve better precipitation. The polymer precipitated out is transparent with some elasticity. This indicates that the polymer precipitated out is PMMA polymer that is cross-linked with the cinnamic acid. Filtration process was used next in order to isolate the precipitate form from the methanol solution by using the vacuum pump. After that, the second purification was conducted as to achieve the higher purification. The purified PMMA polymer was analyzed by UV method in the range of 300 to 200 nanometer. UV spectroscopic analysis was used to confirm the removal of the cinnamic acid in the precipitation process. UV analysis gives one major peaks in the first and second purification individually, as I have mentioned before. So we can see the value of the wavelength and the absorbance for the first and second purification in this table. So in order to make sure that the experiments run smoothly, some precautions need to take note. Firstly, the polymer collected must be dried overnight in an oven to remove all the solvent so that the solvent peak is not observed in the spectrum. The polymer collected must be stored well in the oven to avoid the contamination. Then, to make sure the width of the purification sample for the UV test is weighed before dissolve it with acetonitrile so that we can calculate the info needed. Lastly, please make sure that the volumetric flask for UV test is clean and dried properly. So for the conclusion, the objective of these experiments was achieved. Separation and purifications of PMMA has been carried out quantitatively, so we can get the weight percents of the cinnamic acid in polymer 1 and polymer 2. So the weight percentage of the cinnamic acids in polymer 1 is 1.52%, while the weight percentage of the cinnamic acids in polymer 2 is 1.64%. So that's all for my presentation. Thank you.